Find a clear night, step outside, and look up. Count what you can see with nothing but your eyes and patience. On a perfect night, far from city lights, you might reach a few thousand stars before losing track. That number feels large until you understand what it actually represents. Each of those points of light is a sun, a furnace burning across an incomprehensible distance of empty space. And around almost every single one of them, planets are orbiting right now in the dark. Rocky ones, frozen ones, gaseous ones the size of small stars. Worlds so varied that no single imagination could have invented them all. Most of those worlds will never be visited, never be photographed, never be understood in any meaningful detail. But some of them have already been found, confirmed, and studied by NASA and major research institutions across the globe. And some of them are so wrong, so fundamentally broken by every instinct we have about what a planet should be, that the scientists who first detected them assumed their instruments had failed. Tonight, 10 of those worlds are going to be examined one by one. A planet being slowly eaten alive by the star it orbits, losing mass every single day it exists. A world so completely black that coal sitting beside it would look like polished silver under bright light. A ring system so enormous in diameter that it would swallow the entire orbital path of Venus around our sun. None of these are theoretical constructs or speculative models built on incomplete data. Every world in this list has been confirmed through rigorous observation, peer review, and independent verification by NASA and leading research institutions. The universe did not ask permission before building them, and did not consult any reasonable expectation of what should be possible. These planets exist whether or not they make sense to us. And the first one on this list is already dying, has been dying for longer than human civilization has existed, and still has roughly 10 million years left to go. There is a planet 1,400 light years from Earth that astronomers have been watching with something close to morbid fascination for years. It is called WASP 12b, and by any reasonable scientific standard, it is already a dead world. The process that will erase it completely from existence began long before any human being ever looked at the night sky and wondered what was out there. What makes WASP 12b remarkable is not just the violence of what is happening to it, but the slow, mechanical certainty with which it is all unfolding. There is no event that could reverse this trajectory, no orbital shift that could pull it back from what it has become. The planet crossed a threshold at some point in its history, and everything since that moment has been consequence. It orbits its host star so closely that a single complete year on this world lasts just one Earth days. That is not a poetic exaggeration or a simplified approximation for a general audience. In just over 24 hours, WASP 12b completes one full orbit around its star and begins the next one immediately. To understand what that proximity means physically, it helps to consider what gravity does at close range. On Earth, the moon's gravity is distant enough that its tidal effects on our planet are subtle, expressed mainly through ocean tides and a very slow lengthening of our days over geological time. The relationship is gentle, almost polite, operating across a distance of roughly 384,000 kilometers. WASP 12b does not have that luxury of distance. It orbits its star at a fraction of the distance between Mercury and our own sun, close enough that the gravitational field it moves through is not a background force, but a dominant physical reality. The star's tidal forces acting on WASP 12b at that range are not merely strong, they're structurally catastrophic. They exceed by an enormous margin anything experienced by any planet in our solar system, including the most volcanically stressed moons of Jupiter. And the result of that stress is visible in the planet's shape itself, which is the first thing that signals to any observer that something here has gone fundamentally, irreversibly wrong. WASP 12b is no longer a sphere. That fact alone deserves a moment of stillness, because every planet we have ever known, every world ever studied in our solar system, holds itself together through gravity into something approximately round. Spherical shape in a planet is not an aesthetic preference. It is physics expressing itself at the most basic level of mass and self-gravity. WASP-12b's own gravity is no longer the dominant force shaping it. The star's tidal pull has overwhelmed the planet's structural integrity and physically deformed it into the shape of an egg. One side bulges outward toward the star, stretched by the gravitational gradient. The other side elongates in the opposite direction, pulled by the same forces operating across the planet's diameter. The planet is being kneaded like material in the hands of something that does not notice or care what it is destroying. No planet in our solar system, not even Io, with its relentless volcanic torment driven by Jupiter's tidal flexing, experiences anything approaching this level of continuous structural deformation. WASP-12b is being reshaped in real time, and the reshaping is only one part of what is happening to it. The star is not just bending WASP-12b, it is consuming it. Material from the planet's upper atmosphere is being continuously stripped away by the combined force of the star's gravity and its radiation, pulled free of the planet and flowing outward in a stream of superheated gas moving toward the star itself. Astronomers have observed this process directly, watching the evidence of it in the spectral data gathered by space-based telescopes and ground observatories. This is not a theoretical prediction or a modeled outcome. It is something that has been seen and measured and confirmed. The planet is bleeding into space, and the rate of that loss has been calculated. WASP-12b sheds the equivalent of several Earth masses of material every million years, a number that sounds slow until you consider what it means across the timescales involved. The planet is not stable. It is not in equilibrium. It is in a state of continuous and accelerating loss from which no natural process will rescue it. In approximately 10 million years, WASP-12b will be gone entirely. Not transformed, not relocated, not dormant. Gone, consumed, erased from the inventory of planets orbiting that star. 10 million years is a span of time that resists intuitive comprehension, but the universe handles it without difficulty. For context, 10 million years ago, the ancestors of modern humans had not yet appeared on Earth. The planet that will vanish in that time frame is already so far into its destruction that what remains is essentially the final chapter of a very long story. What the first chapter looked like is something astronomers can only infer. WASP-12b was almost certainly, at some earlier point in its history, an ordinary gas giant, unremarkable by the standards of the galaxy, orbiting at a distance that posed no existential threat to its continued existence. Something changed that orbit, some gravitational interaction or dynamic instability that pulled it inward toward its star, past the point where the forces it encountered became stronger than anything holding it together. That transition, the crossing of the threshold from which there is no return, is the detail that makes WASP-12b something more than just a dramatic example of planetary destruction. It is a reminder that stability in a planetary system is not guaranteed, that orbits are not fixed tracks, but dynamic relationships that can shift over time. A planet that was once safe is now being erased, and the process between those two states was not sudden. It was gradual, incremental, each orbit bringing it fractionally closer, each fraction increasing the tidal stress, each increase accelerating the atmospheric loss. The planet did not fall into destruction all at once. It walked there slowly, over millions of years, across a distance that looked safe until it no longer was. That slow inevitability is what separates WASP-12b from a simple catastrophe and makes it something closer to a tragedy in the astronomical sense of the word. There is a particular quality to the silence that surrounds a world like this one. It orbits a star that is, by stellar standards, entirely ordinary. It sits in a region of the galaxy that contains nothing unusual. No nearby supernovae, no exotic radiation sources, no anomalous gravitational neighbors that would draw special attention to this corner of the Milky Way. And yet 1,400 light-years from Earth, in that completely unremarkable location, a planet is being pulled apart atom by atom, its atmosphere flowing away into space, its shape distorted beyond anything its own gravity can correct. NASA and the research institutions that have studied this system have confirmed every element of what is happening there. The instruments were not broken when the data first came in. The data was simply describing something that had never been seen before, a planet in the final, drawn-out stages of being erased by the very star it orbits. What remains of WASP 12b right now, at this moment, is a deformed, egg-shaped gas giant bleeding mass in space, locked in an orbit that is also a sentence with no appeal and no end date, except the one already calculated. It completes that orbit, everyone. 1 days, cycling through its destruction with a regularity that makes the whole process feel almost mechanical. The star pulls, the atmosphere flows, the shape distorts, and the orbit continues. Whatever this planet was before it crossed into this territory, whatever its history looked like in the billions of years before the tidal forces took hold, that version of WASP 12b no longer exists. What exists now is the aftermath of a crossing, a world that made it past the point of no return and has been paying for it ever since. And somewhere in the remaining 10 million years of its existence, without ceremony or witness, it will finish dying. What finished WASP 12b was not a single catastrophic event, but the slow arithmetic of proximity catching up all at once. The next world on this list operates by a different kind of extremity, one that breaks a rule so fundamental that astronomers spent years checking their calculations before accepting it. That rule is simple and has held without exception across every star system ever studied until now. Stars are hot, and planets orbiting those stars are cold by comparison, always and without exception. The temperature hierarchy between a star and its planets is not a suggestion or a tendency. It is one of the most reliable organizing principles in all of astrophysics. Every model, every simulation, every observation across decades of planetary science confirmed this relationship as essentially inviolable. Then a gas giant located 670 light-years from Earth was measured, and the number that came back from the instruments was so far outside any reasonable expectation that the first instinct of the researchers reading it was to look for the error. There was no error. The planet's dayside surface temperature exceeds 4,300 degrees Celsius, a number that does not belong in the planetary column of any table ever constructed by astronomers. That number belongs in the stellar column, and it sits there comfortably because Celt 9b is hotter than approximately 80% of all known stars in the Milky Way. The star responsible for this is not a typical one, and that context matters enormously when trying to understand how a planet ends up in this condition. Celt 9 is a blue-white star, young and extraordinarily energetic, radiating at intensities that most stellar objects never approach during their entire lifetimes. It is the kind of star that represents a category of extreme rather than a point on a normal distribution, a furnace operating well above the average output of the galaxy's stellar population. Celt 9b orbits this already exceptional star at a distance so close that a single year on the planet lasts just 1.5 Earth days. Like WASP 12b before it, this proximity has consequences that extend far beyond simple heating. Consequences that reshape the planet's entire physical character from the atmospheric chemistry down. The planet is tidally locked, meaning the same hemisphere faces the star at all times, absorbing a continuous and unrelenting flood of radiation without the relief of rotation, without the cycle of day and night that distributes energy across a planetary surface. One side of this world has been staring into that blue-white furnace since the planet formed, and the results of that unbroken exposure are written into the atmosphere in a way that has no parallel anywhere else in the known universe. At 4,300 degrees Celsius, something happens to matter that requires a moment of careful consideration before the full weight of it registers properly. This is not simply a question of extreme heat in the way that a volcanic surface or a lava ocean is extreme heat, though both of those things would be trivially destroyed here. The temperature on Celt 9b's dayside is sufficient to break the chemical bonds between atoms themselves, which means that the concept of molecules on this planet's sun-facing hemisphere is not merely impractical, but physically impossible. Water cannot exist as a molecule at these temperatures, not because it evaporates or dissociates in the conventional sense, but because the thermal energy present is greater than the binding energy holding hydrogen and oxygen together in the first place. Carbon dioxide cannot exist as a molecule here. Hydrogen gas, the simplest and most stable molecular form of the most abundant element in the universe, cannot exist as a molecule here. Everything that arrives at the day side of Kelt, 9b as a compound, is immediately torn apart into its constituent atoms, reduced to a plasma of individual particles with no chemical structure remaining whatsoever. The atmosphere is not a mixture of gases in any conventional sense of that term. It is a collection of dissociated atoms, suspended in a thermal environment that prevents them from ever recombining into anything more complex. The implications of that atmospheric state for anything attempting to exist within it are worth spelling out with some precision, because the usual vocabulary of danger fails here in an instructive way. Consider what burning means as a physical process. Combustion requires molecules, specifically molecules that can react with oxygen through a chain of chemical interactions that release energy as heat and light. There are no molecules on the day side of Kelt, 9b. The oxygen is there, in the sense that oxygen atoms are present, but they are not bonded to anything and cannot sustain a combustion reaction. You would not burn in this atmosphere. Burning is simply not available as a mechanism of destruction at these temperatures. What would happen instead is dissociation, the same process happening to the atmosphere applied to whatever biological or material structure entered it. The chemical bonds holding cells together, holding proteins in their functional configurations, holding any organized structure in its organized state, will be broken before any other sensory experience registered. This is not a more dramatic version of being burned. It is a categorically different process, and the distinction matters because it illustrates how completely this environment operates outside the parameters where ordinary physical intuition applies. There is something almost philosophically disorienting about a planet that is hotter than stars, and the disorientation does not diminish with familiarity. A star is defined in part by its temperature, by the nuclear processes that generate the heat that makes it what it is. Kelt, 9b, has no nuclear fusion occurring within it, no internal energy source driving its temperature to these levels. Every degree of that 4,300 degree surface reading comes from external bombardment, from the radiation pouring off Kelt, 9, and striking the planet's atmosphere in quantities that overwhelm any natural cooling mechanism. The planet is not generating this heat. It is receiving it and being unable to shed it fast enough to bring the temperature down to anything resembling what a planet should be. The energy budget of this world is so catastrophically imbalanced between input and output that the dayside temperature has climbed past the point where stars are defined and kept climbing. It sits there now, in a thermal regime that belongs to a different category of object, wearing a temperature that nothing without nuclear fusion has any business wearing, and doing so simply because it cannot find a way to get rid of the energy arriving faster than it can be radiated away. The night side of Kelt, 9b, presents its own set of conditions that, by any standard not involving the day side of the same planet, would qualify as extreme in their own right. The temperature differential between the two hemispheres drives atmospheric dynamics of extraordinary violence, with material from the day side attempting to flow toward the cooler night side in pressure-driven currents that carry dissociated atomic matter across the terminator. Some of those atoms recombine on the night side as temperatures drop to levels where molecular bonds can briefly hold, creating a chemistry that is constantly being assembled and then destroyed on each circuit of the atmosphere. The night side temperature, while cooler than the day side by a significant margin, is still hot enough to make it one of the more hostile environments in the cataloged universe. The word cooler is doing significant work in that sentence, because cooler in this context means temperatures that would still vaporize most materials humans have ever worked with. The contrast between the two hemispheres is not a contrast between hostile and hospitable. It is a contrast between two different categories of hostile, one of which happens to be hotter than most stars. Kelt 9b is also being destroyed, though the mechanism here is different from the tidal consumption consuming WASP 12b in the previous entry on this list. The radiation from Kelt 9 is gradually stripping the planet's atmosphere away layer by layer, a process called photoevaporation that operates across a much longer time scale than tidal mass loss, but arrives at the same destination. Each high-energy photon striking the upper atmosphere carries enough energy to accelerate atmospheric particles past the planet's escape velocity, sending them streaming away into space on a one-way trajectory. The rate of this loss is significant enough that models of the planet's future converge on a consistent outcome. Over the course of several 100 million years, the atmosphere will be progressively thinned, the layers peeled back one by one, until what remains is a bare planetary core sitting at the edge of a star that has finished consuming everything around it. A cinder is the word astronomers use, and it is the right word, conveying both the remnant nature of what will be left and the process that reduced it to that state. The word implies something that was once more consumed down to its irreducible minimum, and that is exactly what Kelt 9b is in the process of becoming. What makes Kelt 9b linger in the mind after the fact have been absorbed is not any single number, but the combination of violations it represents simultaneously. It is a planet hotter than stars. It is a planet whose atmosphere cannot contain molecules. It is a planet being slowly dismantled by the same radiation that makes it so extreme. Each of those facts would be remarkable in isolation, and Kelt 9b manages all three at once, existing in a state that seems to accumulate impossibilities the way ordinary planets accumulate moons. The scientific literature on this object is extensive precisely because each new measurement tends to produce a result that requires some existing model to be revised or discarded. It is a useful planet in that sense. Useful not for any purpose a living thing might value, but useful as a stress test for theories of planetary physics, a place where the equations are pushed to their outer limits and sometimes past them. The galaxy contains billions of planets, and the overwhelming majority of them are unremarkable by the standards of this list. Kelt 9b is not one of those. It is the kind of object that reminds researchers why the universe resists being fully described in advance. Now turn from a planet defined by its temperature to a planet defined by its deception, because the next world on this list commits a particular kind of cruelty that is worth examining on its own terms. HD 189733b sits 64 light-years from Earth, close enough by galactic standards to be one of the most thoroughly studied exoplanets in the confirmed catalog. It is a deep, vivid cobalt blue, a color so similar to Earth's appearance from orbit that the first instinct of anyone seeing the data is something close to recognition. That recognition is the trap. The blue of HD 189733b does not come from oceans or liquid water or any of the things that make Earth's color meaningful from a distance. It comes from silicate particles, microscopic fragments of glass suspended throughout the planet's atmosphere in quantities sufficient to scatter blue wavelengths of light across the entire visible disk. The color is identical to the color of hope, and the cause is entirely unrelated to anything hope should attach itself to. This planet announced its presence to the universe wearing the color of a world that might be habitable, and spent every subsequent measurement demonstrating that it is one of the most lethal environments ever confirmed. The winds on HD 189733b reach 8,700 kilometers per hour, a figure that requires a reference point before it can be properly felt. The fastest sustained winds ever recorded on Earth peaked at around 400 kilometers per hour, a speed associated with the most violent atmospheric events ever documented in human history. The winds on this planet are more than 20 times that, fast enough that the comparison to terrestrial storms stops being useful almost immediately. A Category 5 hurricane, the benchmark for maximum terrestrial wind violence, will be a negligible disturbance by the standards of HD 1897333b's permanent atmospheric state. Those winds carry the silicate particles suspended in the atmosphere not downward as rain falls on Earth, but horizontally, driven in a continuous planetary storm that has been running without interruption since before Earth's continents reached their current positions. The temperature differential between the planet's day side and night side, approximately 260 degrees Celsius, drives this circulation in a loop that has no off-season, no calm hemisphere, no region of the atmosphere where the glass-laden wind slows to anything survivable. The surface temperature sits at around 1,000 degrees Celsius. The glass would not drift down onto you the way weather arrives on Earth. It would arrive from the side at supersonic velocity, and the word for what follows is not burning and not freezing, but something that has no comfortable name. This planet offered the universe a beautiful face and built something that destroys everything behind it. And the next world on this list takes a different approach entirely to being somewhere nothing should ever go. The next world on this list takes deception in a completely different direction, replacing beauty with something closer to absolute erasure. There is a planet 750 light years from Earth that does not reflect the universe back at anything observing it. It does not shimmer, does not catch starlight, does not betray its own presence through any conventional optical signature that telescopes expect to find. It absorbs. That is the word that matters here, and it matters with a precision that ordinary language was never designed to carry. 3-2b absorbs 99. 9% of every photon of light that strikes its surface and atmosphere. A figure so complete that the remaining fraction barely registers as a measurement at all. Coal, one of the darkest naturally occurring substances on Earth, reflects approximately 5% of incoming light. Black acrylic paint, engineered specifically to minimize reflection, gives back around 4%. Trace, 2b reflects less than 1% of anything that reaches it, making every dark material humans have ever named or manufactured look luminous by direct comparison. NASA called this world the planet of eternal night. And for once, that kind of institutional language is not reaching for drama, but simply describing what the data shows. The designation is accurate in a way that resists comfortable absorption, because eternal night is not a metaphor here, but a physical condition written into the planet's reflective properties at a fundamental level. Every wavelength of visible light arriving from the host star, every photon that makes the journey across whatever distance separates the star from this world, simply disappears upon contact. There is no bouncing back, no scattering, no partial return of any signal that would tell a distant observer this object exists by anything other than inference. The planet is present in the data only because of what it blocks and what it does not return, an absence shaped like a world, detectable only by the shadow it casts across measurements rather than by anything it contributes to them. That quality of existing as a subtraction rather than a presence gives Trace to be a character unlike anything else on this list. Here is where Trace 2b introduces its particular cruelty, the detail that elevates it from merely dark to genuinely disquieting in a way that takes a moment to fully assemble. The planet orbits its host star at a distance so close that a single complete orbit takes just 2.5 Earth days, a proximity that places it among the most intensely irradiated objects in the confirmed planetary catalog. It is not sitting in some remote, cold corner of its system, quietly absorbing whatever faint starlight drifts its way across a vast orbital distance. It is close, extraordinarily close, bathed constantly in an enormous and relentless flood of stellar energy arriving from a star it never moves far from at any point in its orbit. All of that energy arrives at the surface and atmosphere of Trace 2b with the full force of that proximity behind it. Almost none of it leaves. The planet receives and receives and receives, and the darkness swallows it all without returning any of it in the wavelengths that would make the world visible to anything looking in its direction. The result of that imbalance between energy arriving and light departing is a temperature that sits at around 1,000 degrees Celsius on the planet's day side, a heat built entirely from absorption with nowhere to escape through reflection. That number places Trace 2b in the same thermal range as several other worlds on this list, but the context here is different in a way that changes the character of the heat entirely. On most hot planets, some fraction of incoming energy is reflected away, which means the temperature represents a partial accounting of what the star delivers. On Trace 2b, the temperature represents almost the full accounting, nearly every joule of energy that arrives converted into heat, because almost nothing is turned away at the door. The planet is a near-perfect thermal trap, and the consequence of that efficiency is a surface radiating not reflected light, but emitted heat, a faint thermal glow in the deep red range, visible only as warmth rather than brightness. Standing on the surface of Trace 2b, the experience would be one of total and absolute darkness surrounding a warmth coming up from beneath your feet. There would be no light from the star above reaching your eyes in any usable quantity, no glow from the atmosphere, no reflected illumination from any surface nearby. The darkness would be complete in the way that the interior of a sealed room with no light source is complete, except that the ground beneath you would be radiating a dull red warmth like the surface of a cast iron stove hours after the fire inside it has been extinguished. Not bright, not visible in any conventional sense, but present as heat rather than light, a planet announcing itself through temperature rather than through any photon it was willing to return. That image, embers long after the fire has gone cold, is the one that fits this world most precisely, and it requires no embellishment to be unsettling. Scientists have spent considerable effort attempting to explain why Trace 2b absorbs light to this degree, and the honest answer is that the models have not yet caught up to the observation. The leading candidates among atmospheric compounds are sodium, potassium, and titanium oxide, chemicals known to absorb light effectively in laboratory conditions and present in the atmospheres of other hot gas giants studied at comparable distances from their host stars. Each of those compounds contributes to the absorption budget in ways that are well understood individually. The problem is that even accounting for all of them together, the theoretical models do not fully explain an absorption rate this close to total. Something about this planet drinks light in a quantity and across a wavelength range that current atmospheric chemistry has not yet been able to account for completely. The planet is darker than the science that attempts to describe it, which is itself a remarkable position for a confirmed, well-studied object to occupy. What Trace 2b represents, taken as a whole, is a world that exists at the intersection of two conditions that should not logically occupy the same object simultaneously. It is one of the most irradiated planets in the confirmed catalog and one of the most completely dark. Those two facts sit beside each other in the data, without resolving into anything comfortable or intuitive, demanding instead that the observer hold both of them at once and accept that the universe found a way to build something that is simultaneously bathed in light and incapable of showing it. The planet is being bombarded constantly and responding to that bombardment with silence, absorbing everything and returning almost nothing, a world that has found a way to make enormous stellar energy disappear without a trace into the fabric of its own atmosphere. That is not a description most planetary scientists expected to write about any real object before this one was found. The planet that follows Trace 2b on this list abandons darkness entirely and moves instead into a different category of geological horror, one built from heat and cycles and the behavior of rock under conditions that make Earth's most violent volcanic events look like minor surface adjustments. K2-141b sits approximately 200 light-years from Earth and orbits its stars so quickly that a full year on this world lasts just under 7 hours. The proximity that produces that orbital speed also produces a surface environment on the star-facing hemisphere that exceeds 3,000 degrees Celsius, a temperature at which the distinction between solid rock and liquid rock becomes irrelevant because both conditions exist simultaneously across a global magma ocean covering the entire dayside surface. Hawaii's volcanic coastline, where lava meets ocean and the two substances negotiate their boundary in a process of continuous violent exchange, provides the closest terrestrial reference point, but it is a reference point that fails almost immediately when applied to K2-141b scale and intensity. At 3,000 degrees, the magma ocean on K2-141b does something that magma on Earth never does, because Earth has never been hot enough to require it. The rock evaporates. Sodium, silicon oxide, silicon monoxide, all of the mineral compounds that make up the planetary crust on the dayside, vaporize at the surface and rise into a thin, hot atmosphere of rock gas that sits above the magma ocean like steam above boiling water. Except that the steam here is made of minerals that would be solid stone at any temperature Earth has ever naturally produced. Those vaporized minerals are then carried by supersonic winds driven by the temperature differential between the 3,000-degree day side and the night side, which plunges to around minus 200 degrees Celsius. A gap of more than 3,200 degrees across a single planetary diameter that generates atmospheric dynamics of extraordinary violence and speed. The rock vapor crosses to the night side, cools, condenses, and falls as rain. Not water rain, not acid rain, not any category of precipitation that Earth's meteorological vocabulary has a comfortable name for, but mineral rain, sodium and silicate particles falling from the sky onto a surface cold enough to receive them as solid deposits. Those deposits accumulate on the night side surface, some of them collecting in frozen mineral fields, some of them slowly migrating toward the edge of the dayside magma ocean, where the temperature rises enough to melt them back into the cycle that will carry them up again as vapor. The planet rains its own mountains back onto itself, continuously and without pause, in a geological cycle operating at temperatures and velocities that dwarf anything Earth's most active tectonic systems have ever produced. That cycle has no end condition, no equilibrium point where it slows and stops. Just rock rising and falling and rising again. A world perpetually consuming and rebuilding itself from the same material, forever. That cycle has no natural conclusion, no point where the arithmetic of rock and heat and wind resolves into stillness. The two worlds that follow exist at opposite ends of a spectrum that has nothing to do with violence or destruction, and everything to do with time. One of them is so young that it still carries the heat of its own birth in its atmosphere, radiating that warmth outward as color, as light, as something visible from Earth across 57 light-years of empty space. The other is a world wrapped in fire, sitting on a fortune that nothing alive will ever reach, orbiting a star close enough to see on any clear night from any dark field in the American countryside. They're not similar worlds. They're not related by any physical process or orbital circumstance. What connects them is the quality of wonder they produce before the facts arrive to complicate it, and the way those facts, once absorbed, change the character of that wonder entirely without diminishing it. GJ504b sits 57 light-years from Earth, a distance that places it among the closer confirmed exoplanets in the current catalog, close enough that astronomers have done something they can do for almost no other world on this list. They have photographed it directly, captured actual light from this planet in an actual image, a small bright point sitting beside its host star in photographs that exist and can be examined by anyone who looks for them. That act of direct imaging is rarer than it sounds, because the technical challenge of resolving a planet's light from the overwhelming glare of its host star is enormous. And most exoplanet detections rely on indirect methods that infer the planet's existence without ever capturing a photon it has emitted or reflected. GJ504b appears in those photographs as a distinctly pink point of light, a color that requires explanation before it makes any sense at all, because gas giants are not supposed to glow pink from their own internal processes without a very specific reason behind it. That reason is age, or more precisely the absence of enough of it to matter at a planetary scale. GJ504b is approximately 160 million years old, a number that sounds ancient by any human standard and is essentially newborn by the standard the universe applies to planets. For comparison, the dinosaurs that went extinct 66 million years ago had already been walking the Earth for roughly 170 million years before the asteroid ended their tenure, meaning GJ504b is younger than the entire span of the dinosaur era from beginning to end. Jupiter, for reference, formed approximately 4.5 billion years ago, a time frame so much larger than GJ504b's age that the ratio between them becomes difficult to hold in a single thought without losing something in the translation. This planet has not had time to become what planets eventually become, which is the key to understanding everything unusual about it. When a gas giant forms, the process is not quiet or gradual in the way that word sometimes implies. Enormous quantities of gas and dust collapse inward under their own gravity, and that inward collapse converts gravitational potential energy into heat through a process as fundamental as any in physics. The planet that emerges from that collapse is not cold. It is hot, genuinely hot. Not for nuclear fusion as a star would be, but from the sheer mechanical violence of all that material falling inward and compressing into a single massive object. A newly formed Jupiter-class planet carries an enormous thermal inheritance from its own creation, and over billions of years, that heat slowly bleeds away into the surrounding space, the planet cooling and dimming as the millennia accumulate. GJ504b has had 160 million years to complete that cooling process, which sounds like plenty of time until you understand that it is nowhere near enough. The heat from GJ504b's formation is still present, still radiating outward from the planet's atmosphere in quantity sufficient to push the surface temperature to around 230 degrees Celsius. That temperature is not coming from the host star's radiation, not from any external energy source, not from any ongoing internal process comparable to nuclear fusion. It is the residual warmth of creation itself, the thermal echo of a gravitational collapse that happened 160 million years ago and has not yet finished dissipating into the cold of space. That warmth is what produces the color. At 230 degrees, the planet emits thermal radiation in wavelengths that translate visually into a deep magenta, a pinkish purple that appears in the direct images not as a reflected color borrowed from starlight, but as something the planet generates from its own interior. GJ504b is not reflecting pink. It is emitting it, glowing with the last warmth of its own birth the way a coal holds color long after the fire that heated it has gone out. The planet is 4 times the mass of Jupiter, which places it in a category of gas giant, where the word large begins to feel inadequate almost immediately. Gravity at the cloud tops of GJ504b is approximately 10 times what a person standing on Earth experiences, a figure that matters not because anyone will ever stand there, but because it illustrates the scale of what is operating beneath those pink clouds. At 10 times Earth's gravity, the human cardiovascular system cannot function correctly, cannot push blood upward against the weight pressing the body downward, cannot maintain the circulation that keeps the brain supplied with what it needs to remain conscious and alive. The planet would not need to do anything dramatic to end a human presence within its atmosphere. It would simply need to be what it already is, a world where gravity alone is enough to make existence impossible before any other condition has a chance to register. In a billion years, GJ504b will look entirely different from how it appears in those photographs today. The birth heat will have continued its slow dissipation into space. The surface temperature will have dropped to something much closer to what other gas giants of similar mass and orbital distance display, and the pink color will have faded with it. The planet will still exist, still orbit its host star, still be 4 times Jupiter's mass, and carry all the other characteristics that define it physically. But the glow will be gone, replaced by reflected starlight in whatever wavelengths the atmosphere scatters, indistinguishable in color from dozens of other gas giants in the same stellar neighborhood. What makes GJ504b worth pausing over is precisely that it is being observed at a moment that will not last. A window in its multi-billion-year existence when its own history is still visible on its surface, still radiating outward, still announcing what it recently was to anyone with the instruments to read the signal. There is something genuinely affecting about a planet that is still in the process of becoming itself, still settling into the configuration it will eventually hold for billions of years, still carrying the thermal signature of the event that made it. Every other world on this list is defined by what it is doing to itself or having done to it, by processes of destruction or extremity that are actively underway. GJ504b is defined by something more elemental than destruction, by the simple fact of recent existence, by the residual energy of formation that has not yet finished working its way out into the surrounding void. It is a world in transition, cooling toward its permanent state, and the color it wears right now is the color of that transition, visible across 57 light years to anyone who knows what they're looking at and why it will not always look this way. Now turn from a world glowing with the warmth of its own birth to a world that sits 41 light years from Earth, close enough that its host star is visible to the naked eye on any clear night from any reasonably dark location across the continental United States. That proximity matters because of what it means for the relationship between this planet and the civilization that discovered it. This is not a distant abstraction requiring enormous telescopes and years of data collection before the star itself becomes real to a non-specialist. The star is already visible, already present in the sky above any American backyard on a clear evening, already part of the night that anyone can look up into without any equipment at all. And orbiting that familiar, visible star, confirmed and studied and measured with the full resources of modern astronomy, is a world that produced one of the most startling single sentences ever written in a scientific paper about a planetary body. In 2012, astronomers analyzing the mass, radius, and internal composition of 55 Cancri arrived at a conclusion that required several readings before the implications fully assembled themselves. The planet's physical parameters pointed toward an interior made largely of carbon compressed under the internal pressures of a super-Earth into its densest possible crystalline form. Not carbon-bearing rock, not carbon compounds mixed with silicates and metals in the proportions that characterize every planet in our solar system, but compressed crystalline carbon in quantity sufficient to constitute the dominant structural material of the planetary interior. A world of diamond, orbiting a star you can see tonight without a telescope, sitting 41 light years away and holding within it the most compressed, most valuable mineral structure that any confirmed planet had ever been proposed to contain. Later models complicated that picture, introducing alternative high-pressure mineral structures that could account for the same observational data without requiring a diamond interior of quite that purity or scale. What those later models did not do was make the surface any less extreme, because the surface of 55 Cancri is something every model agrees on completely, regardless of what lies beneath it. The orbital period of 55 Cancri is 18 hours, a year shorter than a single Earth day, a proximity to its host star that produces conditions on the dayside surface that no refinement of the interior model changes or softens in any way. The temperature on the sun-facing hemisphere reaches approximately 2,400 degrees Celsius, sufficient to maintain a global ocean of lava across the entire dayside surface, churning and circulating above whatever lies beneath it. Silicate rock evaporates from that lava surface and rises into a lower atmosphere of mineral vapor, forming clouds that catch the lava's own glow and scatter it back downward, so that the sky above the magma ocean shimmers with reflected heat rather than reflected starlight. The host star, less than 2 million kilometers away at closest approach, fills an enormous portion of that sky, a presence so dominant and close that the word star stops feeling like the right category for what is hanging overhead. Beneath that sky, the lava ocean. beneath the lava ocean. If the original 2012 interpretation holds even partially, the most extraordinary mineral interior ever proposed for a confirmed planetary body, inaccessible, indestructible by any technology humanity has ever conceived, wrapped permanently in fire at a temperature that makes the surface of Venus look temperate by comparison. The wealth is there, the fire is there, and the distance between the two and anything that could ever reach them is absolute. Two worlds remain before this list reaches its final entry, and they could not be more different from each other. The first of them sits approximately 460 light-years from Earth in the constellation Ophiuchus, a region of sky that most people have never deliberately looked toward with any particular intention. It is called ROXS 42b, and it belongs to a very small category of exoplanets that have been directly photographed, meaning actual light from this object has been captured in actual images that exist in scientific archives. That fact matters because it means this world is not an inference built from indirect measurements or a signal extracted from the noise of transit curve. It is a point of light in a photograph, sitting beside its host star, visible and real in a way that most exoplanets never become for anyone studying them. What the photographs reveal, and what the spectroscopic data gathered alongside them confirms, is an object that strains the vocabulary of planetary science. In almost every direction it can be pushed before that vocabulary simply gives out entirely. The radius of ROXS 42b is approximately 2.5 times that of Jupiter, a number that requires a moment of deliberate consideration before it settles into anything resembling comprehension. Jupiter is already a planet so large that every other planet in our solar system combined would fit inside it with room remaining for several more attempts at the same exercise. ROXS 42b dwarfs Jupiter the way Jupiter dwarfs Earth, a scaling relationship that removes any intuitive anchor a person might try to hold onto while processing it. The mass of this object sits somewhere between 6 and 9 Jupiter masses, depending on which model is applied to the available data, a range of uncertainty that is itself larger than the mass of several terrestrial planets. For times the mass of Jupiter, which made GJ504b feel enormous in a previous entry on this list, would sit comfortably within the lower end of ROXS 42b's estimated mass range, and still leave room for more planet on top of it. Jupiter, measured against this object, is not a giant, but a reference point, a unit of comparison that now feels almost quaint. There is a boundary in planetary science that sits at approximately 13 Jupiter masses, the threshold above which an object becomes massive enough to briefly fuse deuterium in its core and qualify as a brown dwarf rather than a planet. Brown dwarfs are failed stars, objects that accumulated enough mass to begin the process of stellar ignition, but not enough to sustain it, stranded between the planetary and stellar categories in a classification no man's land that astronomy has never fully resolved. ROXS 42b sits below that threshold, which means it technically qualifies as a planet under the most widely used definitions currently applied by the research community. But the word planet, applied to an object of this scale, begins to feel like a category error in the same way that calling the Pacific Ocean a puddle is technically accurate about the substance involved while being completely misleading about everything else. ROXS 42b is a planet the way a brown dwarf is almost a star, which is to say it occupies the territory where the definitions were never designed to operate comfortably. What makes the size of this object even more difficult to process is the distance at which it orbits its host star, a detail that adds a layer of strangeness to an already strange object. ROXS 42b sits at roughly 157 times the distance between Earth and the Sun, an orbital radius so enormous that it places the planet far beyond any region where standard planet formation models would predict an object of this mass could have assembled itself from a protoplanetary disk. The conventional understanding of how gas giants form requires a disk of material dense enough to accumulate into a planetary core quickly enough to then capture the surrounding gas before the host star disperses it, a process that works within certain orbital distances and fails outside them. At 157 astronomical units from its star, ROXS 42b is orbiting in territory where that process should not have been able to produce anything close to what is sitting there. Either the planet formed somewhere else and migrated outward, which creates its own set of problems for the models, or it formed the way stars form, through direct gravitational collapse of a gas cloud, which would make it something other than a planet in the most fundamental sense. Gravity at the cloud tops of ROXS 42b is estimated at somewhere between 5 and 8 times what a person standing on Earth experiences, a range that reflects the uncertainty in the mass estimates, but converges consistently on a figure that would make the planet's upper atmosphere one of the most physically demanding environments in the confirmed catalog for any object attempting to exist within it. The atmosphere itself extends thousands of kilometers above what would technically be considered the surface, a definition that already struggles to mean anything precise on a gas giant, where there is no solid boundary between atmosphere and interior, just a gradual transition from gas to increasingly compressed and exotic states of matter as depth increases. The internal pressure at the core of this object, if there's a discrete core rather than a continuous gradient of compression, would exceed anything that material science has been asked to describe or model at a laboratory scale. The planet exists at the outer limits of what the physics of planetary structure can accommodate before the equations themselves begin to break down. Jupiter, the thing that anchored human understanding of planetary scale for the entire history of astronomy before exoplanets were confirmed, would be a moon in the atmosphere of ROXS 42b. That sentence is not a rhetorical flourish designed to produce a dramatic effect in a piece of writing about extreme worlds. It is a straightforward geometric consequence of the size relationship between the two objects, the same kind of statement that could be made about Earth relative to Jupiter and would be equally accurate. The largest planet in our solar system, the one that defined the unit of measurement used to describe every gas giant ever found anywhere in the galaxy, will be a satellite-sized object drifting through the upper atmosphere of this world without reaching anything that could be called its surface. That rescaling of Jupiter from reference point to footnote is perhaps the most viscerally useful way to understand what ROXS 42b actually represents in terms of physical scale, because it takes the familiar and makes it small in a single step. The question of whether ROXS 42b is a planet or a brown dwarf or something that requires a new category entirely remains genuinely unresolved in the scientific literature, and that unresolved status is not a gap in knowledge waiting to be filled by one more observation. It reflects a deeper ambiguity in the way the universe builds large objects, an ambiguity that ROXS 42b inhabits more completely than almost any other confirmed object in the current catalog. The boundary between planets and brown dwarfs was drawn by astronomers to organize a spectrum of objects that the universe produced without consulting any organizational preference. ROXS 42b sits close enough to that boundary, and far enough outside the formation conditions that normally produce objects on either side of it, that its existence challenges the boundary itself rather than simply approaching it from one direction. It is a world that asks whether the categories were ever adequate to describe everything the universe was willing to make, and the honest answer, looking at the data, is probably not. Against ROXS 42b, against the scale and violence and strangeness of everything that has preceded it on this list, the world that follows it is quiet. It does not break records for temperature or darkness or atmospheric horror. It does not occupy ambiguous territory between planetary categories or rein its own geology back onto itself in a continuous geological loop. Kepler 442b, located 1,206 light-years from Earth, is remarkable for an entirely different reason, one that requires a shift in emotional register that feels almost jarring after everything that has come before it. It orbits a K-type star, a class of star that is quieter and more stable than our own sun, less prone to the flares and energetic outbursts that make stellar environments hostile to anything attempting to persist within them. The planet sits comfortably within the habitable zone of that star, at a distance where liquid water could exist on its surface under the right atmospheric conditions, a detail that sounds unremarkable until you consider how many worlds on this list made liquid water impossible before the first sentence about them was finished. Kepler 442b is a rocky planet estimated at approximately 1.3 times the size of Earth, a difference in scale small enough that a person transported there would not immediately register the planet as alien in its fundamental proportions. It receives about 70% of the solar energy that Earth receives from our own sun, a figure close enough to Earth's energy budget that surface temperatures within a range compatible with liquid water and biological chemistry become genuinely plausible rather than merely theoretical. On the Earth Similarity Index, the scientific scale that attempts to quantify across multiple parameters how closely a planet resembles Earth in the conditions it offers, Kepler 442b scores 0. 84 out of a maximum of 0, the highest score ever recorded for any confirmed exoplanet in the current catalog. By every indirect measurement available to modern astronomy, this is the most Earth-like world humanity has ever confirmed exists anywhere beyond our solar system, and that designation has not been displaced since it was established. It is 1,206 light-years away, and that distance is the sentence that ends everything else this planet might mean. The Parker Solar Probe, built and launched by NASA, reached speeds of approximately 690,000 kilometers per hour, making it the fastest spacecraft humanity has ever successfully operated in deep space. A genuine achievement of engineering and ambition that represents the outer edge of what current propulsion technology can produce. At that speed, the journey to Kepler 442b would take approximately 9 million years, a span of time longer than the entire existence of the genus Homo on Earth, longer than every human civilization ever built, combined, multiplied, and extended far beyond anything history has produced or recorded. There is no propulsion concept on any drawing board in any research institution at any level of theoretical development that reduces that journey to a timescale a civilization could plan around or a human being could imagine surviving. The planet exists, confirmed, studied, scored as the closest thing to home ever found, and it sits behind a distance that is its own kind of absolute. Somewhere out there, 1,206 light-years from wherever you are sitting right now, there may be an ocean, a sky, clouds moving across a quieter sun than ours, and we will almost certainly never know. That distance does not ask for your acceptance. It simply is, and the universe built it without leaving any door in it at all. And then there's one world left, and it is the one that makes everything preceding it feel like preparation for something genuinely without scale. J1407b sits approximately 434 light-years from Earth, in a region of sky that offers nothing unusual to the naked eye, nothing that would draw attention or suggest that something unprecedented had been recorded there. The star it orbits is young and sun-like, unremarkable by the standards of any catalog, the kind of stellar object that appears in survey data thousands of times before anything interesting emerges from the numbers surrounding it. In 2012, astronomers working through data from the SuperWASP survey found something that did not fit any category they had prepared for, something that required them to go back through the measurements repeatedly before the conclusion became unavoidable. When J1407b passed in front of its host star, it blocked 95% of the star's light, a figure so far outside any expected range that the instruments seemed more likely to be failing than reporting something real. Jupiter, passing in front of a comparable star, blocks roughly 1% of the light reaching an observer on the other side. The difference between 1% and 95% is not a matter of degree, but of category. The difference between a planet transiting a star and something else entirely passing across it. Working backward from the dimming pattern, analyzing how the light faded and held and faded again across different wavelengths and different moments in the transit, the astronomers reconstructed what had caused it. What they found was a ring system, and the word system does almost nothing to prepare anyone for the actual dimensions involved. The ring structure surrounding J1407b spans approximately 120 million kilometers in diameter, a measurement that requires a solar system reference point before it means anything at all. Venus orbits the Sun at a distance of roughly 108 million kilometers, tracing a path around our star that takes 225 Earth days to complete and defines one of the inner boundaries of our planetary neighborhood. The rings of J1407b are wider than that entire orbital path, wider than the circle Venus draws around the Sun across the full span of its year. If this ring system were placed at the center of our solar system with the Sun at its middle, the outer edge of the rings would extend past Venus's orbit in every direction simultaneously, swallowing that orbital path entirely within the structure's own diameter. Saturn, whose rings are considered one of the great architectural wonders of the known universe and span roughly 282,000 kilometers from edge to edge, would sit at the geometric center of J1407b's ring system and be surrounded by ring material extending millions of kilometers beyond it in every direction. The comparison between the two systems is not a comparison between large and larger, but between a thing and something that makes that thing invisible by proximity. Saturn's rings, seen through even a modest backyard telescope from Earth, produce a response in most observers that has nothing to do with the data and everything to do with the fact that beauty at that scale feels like it requires an explanation beyond physics. The rings are thin, geometrically precise, divided into bands by the gravitational influence of Saturn's moons, a structure so elegant that the first astronomers to observe them through early instruments could not agree on what they were seeing. Those rings have anchored human imagination about the outer solar system for centuries, appearing in textbooks and photographs, and the mental shorthand people use when they think about what a planet with rings looks like. J1407b requires that entire framework to be set aside before the actual dimensions can be absorbed, because Saturn's rings are not a smaller version of J1407b's ring system, but something categorically different in scale. Placing them beside each other for comparison is like placing a coin beside a dinner table and noting that both are round, technically accurate, and completely inadequate as a description of the relationship between them. The ring system of J1407b is not a single uniform structure, but a complex, layered architecture of at least 37 distinct bands, each separated from the next by gaps of varying width and composition. That number, 37 distinct ring bands, already exceeds the structural complexity of anything in our solar system, but is one of those gaps that carries the detail most worth pausing over. At least one of the spaces between the ring bands shows signs of material being cleared away, a pattern consistent with a body orbiting within the rings and sweeping the surrounding material into its own gravitational influence over time. That clearing pattern is not a random gap or a compositional anomaly. It is the early signature of a moon in the process of forming, pulling ring material into itself the way the moons of our own solar system assembled themselves from the early solar disk billions of years ago. The ring system of J1407b is not a finished structure, not a static arrangement of particles orbiting in stable configurations around a central body. It is a construction site, actively building new worlds inside itself, carrying within its own architecture the early stages of a process that will eventually produce objects large enough to be called moons. If J1407b occupied the position in our solar system currently held by Saturn, the visual consequence for anyone on Earth looking upward on a clear night would be one of the more disorienting experiences available to human perception without leaving the planet's surface. The rings would span an area of sky more than 10 times wider than the full moon appears from Earth, a structure so large that it would dominate the night sky in a way that no other single object except the sun and moon currently does. The full moon, at its apparent size from Earth, is already large enough that most people slightly overestimate its angular diameter because the mind struggles to hold the actual measurement against the felt experience of looking at it. J1407b's rings, in that hypothetical position, would make the full moon look like a detail rather than a presence, a small bright circle embedded within a structure that extended across a significant fraction of the visible sky in every direction from its center. That image is not offered as comfort or as wonder in the conventional sense, but as a unit of measurement, a way of making 120 million kilometers mean something that numbers alone cannot carry. The question of what J1407b actually is remains genuinely unresolved, and that unresolved status is not a temporary gap in the data, but a reflection of something the object itself has refused to clarify. The initial transit, the event that revealed the ring system in 2012, has not repeated in the time frame, though would be expected if J1407b were a planet in a stable orbit around its host star. That absence of a second transit is the detail that divides the scientific community into two interpretive camps with legitimate arguments on both sides and no observation, yet that conclusively settles the question. One group maintains the planetary interpretation, proposing that the ring plane is tilted at an angle that prevents further detectable transits from the vantage point of Earth, that the planet is still there, still orbiting, still carrying its extraordinary ring system, simply oriented in a way that hides subsequent crossings from our line of sight. The other group proposes something stranger and in some ways more unsettling, that J1407b is not a planet in a stable orbit at all, but a freely drifting sub-brown dwarf with a protoplanetary disk, a massive object moving through the galaxy without being gravitationally bound to any particular star that happened to pass between Earth and the star at the moment the survey was running. A freely drifting object carrying a ring system of this scale would be one of the more remarkable coincidences in the history of observational astronomy. A chance alignment between a transient wandering body and a monitoring program running at exactly the right moment to capture it. The word coincidence carries a weight here that deserves acknowledgement, because the universe is large enough and old enough that improbable alignments do occur without requiring any mechanism beyond time and scale to explain them. Whether J1407b is bound to its star or moving freely through the galaxy, the ring system recorded in that 2012 data was real, present, measurable, and unlike anything else in the documented catalog of structures orbiting planetary-scale objects anywhere in the known universe. The transit happened, the light curves were recorded, the 37 ring bands were reconstructed from the data, and the gap showing moon formation was identified and confirmed. Whatever interpretation ultimately proves correct about the object's orbital status, none of those findings are in dispute. Something passed between Earth and that star, and it was carrying something extraordinary. The image that the data produces, held in the mind without any further elaboration, has a quality that most astronomical facts do not quite reach on their own. A ring system wider than Venus's orbit, divided into dozens of distinct bands, building moons inside itself in the dark, moving either in a stable orbit around a distant star or drifting freely through the galaxy with no particular destination, is a structure that exists completely independently of whether any instrument ever pointed at it again. It does not require confirmation to continue existing. It does not require understanding to continue turning. Whatever J1407b is, and wherever it currently sits in the galaxy, the rings are there, the gaps between the bands are there, the nascent moon accumulating material within one of those gaps is there, all of it moving in the dark at a distance that makes any direct observation from Earth an act of patience measured in generations rather than years. The universe built this structure without consulting any expectation of what a ring system should be allowed to become. And it has been turning since long before anyone on Earth had the instruments to notice it. There's a particular kind of silence that follows the end of a list like this one. A silence that is not empty, but full of the weight of everything that has just been described without resolution or comfort. 10 worlds, each of them real, each of them confirmed, each of them existing right now, at this moment in the dark beyond any distance a human being will cross in any lifetime or any foreseeable succession of lifetimes. Wasp, 12b is bleeding into its star tonight. Kelt, 9b's dayside, is tearing molecules apart into individual atoms tonight. HD 18973-3b's glass storm is moving at supersonic speed across an entire planetary surface tonight. Trace, 2b is absorbing light and returning almost none of it tonight. K2-141b is raining rock onto its own night side tonight. GJ504b is still glowing pink with the heat of its own formation tonight. Somewhere 41 light-years away, the lava ocean of 55 Cancri E is churning beneath a shimmering silicate sky tonight. ROXS 42b is sitting in the constellation Ophiuchus, too large for the word planet to carry comfortably tonight. Kepler 442b is orbiting its quiet K-type star in conditions that might support an ocean. Tonight, 1,206 light-years away and completely unreachable. And somewhere in the dark, at 434 light-years, we're drifting freely through the galaxy with no fixed address. J1407b is turning its impossible rings through the empty space between stars. The rings are turning right now. At this moment, as you read this sentence, as you consider what it means that a structure wider than Venus's orbit exists somewhere in the same galaxy you were born into. The universe did not build these worlds for any audience, did not arrange them for discovery, did not slow their destruction or their formation to accommodate the pace at which human instruments improved enough to find them. They were here before the first telescope, before the first astronomer, before the first human being looked up at a clear night sky and felt the particular mixture of smallness and curiosity that has driven every act of observation since. If these 10 worlds do anything beyond existing in the dark at their various distances, it is this. They suggest that the night sky above any clear field, counted star by star, is not a ceiling but a catalog, and that almost every point of light in it is orbited by worlds stranger than any single imagination assembled before the data started arriving. Step outside on the next clear night and count what you can see. The strangeness is already there, already turning, already real, waiting in the light of stars that have been shining toward you your entire